It is understandable to feel frustrated when navigating the NEC. Its legalistic language and complex structure can make it challenging to extract information efficiently. There are several reasons for the NEC complexity. Firstly, safety is paramount. The NEC prioritizes electrical safety, hence its focus on precise and comprehensive rules. Secondly, it ensures legal uniformity. It establishes uniform electrical codes across the United States, ensuring consistent safety standards. Thirdly, technical advancements are rapidly introduced. The NEC is constantly updated to keep pace with technological innovations and industry best practices. To cope with the NEC, firstly, break it down into manageable sections. Divide the NEC into smaller sections and focus on one aspect at a time. Secondly, use indexes and tables effectively. The NEC provides cross-references and tables to help you navigate the code. Thirdly, seek professional guidance when needed. Consider consulting with licensed electricians or code consultants to clarify complex issues. Fourthly, practice consistently. The more you work with the NEC, the more familiar you will become with its structure and language. Fifthly, focus on the intent behind the regulations. Remember that the ultimate goal of the NEC is to ensure electrical safety. Understanding the intent behind the rules can help you interpret them effectively. Regarding the example reference to Chapter 9 Table 5 is most likely a typo. The correct reference is Chapter 9 Table 4 for dimensions of conduit and tubing. It's important to address any bias by remembering that the NEC is a vital document that protects electrical workers and the public. While it can be frustrating to navigate, its complexity and precision are essential for maintaining electrical safety. Navigating the NEC can be challenging, but it's crucial for electrical professionals to master its content. By breaking down the code, using resources, seeking guidance, and focusing on intent, you can effectively navigate this essential document. Let's delve into specific strategies and examples to further clarify how to approach the NEC. Firstly, understanding the scope of each article is crucial. Before diving into the details of a specific section, take a moment to understand which types of installations or equipment the article applies to. For instance, Article 250 covers grounding and bonding, which are essential for safety. Knowing that any work involving grounding needs to adhere to Article 250 helps you narrow your focus. Secondly, utilize the definitions provided in Article 100. The NEC includes a comprehensive list of definitions for terms used throughout the code. These definitions are not merely suggestions but are legally binding interpretations. For example, the definition of equipment grounding conductor versus grounding electrode conductor is critical for understanding how grounding systems should be installed. Confusing these terms can lead to unsafe installations. Thirdly, master the art of cross-referencing. The NEC is filled with references to other sections, tables, and articles. Learning to efficiently navigate these cross-references is a key skill. For example, if you're working on a circuit breaker installation, you might start with Article 240 on overcurrent protection. This article will then reference other sections, such as those dealing with specific types of breakers or applications. Fourthly, familiarize yourself with Chapter 9. Chapter 9 contains a wealth of information, including tables for conductor properties, conduit fill calculations, and other essential data. These tables are indispensable for proper installation. For example, Table 4 provides the dimensions and percent area of conduit and tubing, which is vital for calculating how many conductors can be safely installed in a given conduit size. Incorrectly filling a conduit can lead to overheating and potential fire hazards. Fifthly, pay close attention to the fine print notes FPN. While not part of the enforceable code, FPN provide valuable context and background information. They often explain the reasoning behind a particular rule, which can aid in understanding and applying it correctly. Sixthly, understand the role of listing and labeling. The NEC frequently requires equipment to be listed and labeled by a recognized testing laboratory. This listing ensures that the equipment has been tested and meets specific safety standards. For example, luminous lighting fixtures must be listed, and their installation must comply with the listing instructions. Using unlisted equipment or installing it improperly can void warranties and create safety hazards. Seventhly, be aware of local amendments. While the NEC provides a baseline standard, local jurisdictions often amend the code to address specific regional needs or concerns. It is crucial to consult with your local building department to determine if any local amendments apply to your project. Eighthly, develop a systematic approach to problem solving. When faced with a complex electrical design or installation challenge, break the problem down into smaller, more manageable steps. Start by identifying the relevant articles and sections of the NEC. Then, carefully review the requirements and apply them to the specific situation. Ninthly, consider using software and online resources. Several software programs and online resources can help you navigate the NEC. These tools often include search functions, cross-referencing capabilities, and interactive tutorials. Tenthly, join professional organizations and attend training seminars. Organizations like the International Association of Electrical Inspectors (IE) and the National Fire Protection Association (NFPA) offer valuable resources, training seminars, and networking opportunities. These events can help you stay up to date on the latest code changes and best practices. 11thly, focus on understanding the calculations required by the NEC. Electrical calculations are essential for determining conductor sizes, overcurrent protection, and other critical parameters. The NEC provides specific formulas and tables for performing these calculations. For example, calculating the voltage drop in a circuit is crucial for ensuring that equipment receives adequate voltage. 12thly, understand the requirements for different types of occupancies. The NEC has specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. These requirements reflect the unique hazards and challenges associated with each type of occupancy. 13thly, pay attention to the grounding and bonding requirements. Grounding and bonding are critical for electrical safety. The NEC provides detailed requirements for grounding and bonding systems, including conductor sizes, electrode types, and connection methods. 14thly, understand the overcurrent protection requirements. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the types and sizes of overcurrent protection devices that must be used in different applications. 15thly, be aware of the wiring methods permitted by the NEC. The NEC specifies the types of wiring methods that are permitted in different applications. These wiring methods include conduit, cable, and other types of wiring systems. 16thly, understand the equipment installation requirements. The NEC provides detailed requirements for the installation of electrical equipment, such as transformers, motors, and generators. These requirements are designed to ensure that equipment is installed safely and correctly. 17thly, pay attention to the special equipment requirements. The NEC has special requirements for certain types of equipment, such as emergency systems, fire alarm systems, and hazardous locations. 18thly, understand the communication systems requirements. The NEC covers communication systems such as telephone, data, and cable television systems. These requirements are designed to protect communication equipment from damage and to prevent interference with electrical systems. 19thly, be aware of the tables provided in the NEC. The NEC includes numerous tables that provide valuable information, such as conductor ampacities, conduit fill capacities, and equipment grounding conductor sizes. 20thly, understand the examples provided in the NEC. The NEC often includes examples to illustrate how to apply the code to specific situations. These examples can be helpful in understanding the intent of the code. 21stly, remember that the NEC is a living document. The NEC is updated every 3 years to reflect changes in technology and industry practices. It is important to stay up to date on the latest code changes. 22ndly, understand the role of the authority having jurisdiction (AHA). The AHJ is the local agency or individual responsible for enforcing the NEC. The AHJ has the authority to interpret the code and to approve or disapprove electrical installations. 23rd, develop a good working relationship with the AHJ. A good working relationship with the AHJ can help you navigate the code and ensure that your installations comply with the requirements. 24th, always prioritize safety. Safety should always be your top priority when working with electricity. The NEC is designed to protect electrical workers and the public from electrical hazards. By following the code and using safe work practices, you can help prevent electrical accidents. 25th, consider specific examples of code interpretation. For example, Article 210.52 addresses receptacle placement in dwelling units. This section requires that receptacles be spaced no more than 12 feet apart along walls. Understanding the intent behind this rule, which is to minimize the use of extension cords, is crucial for proper application. 26th, delve into grounding electrode systems. Article 250.50 and subsequent sections detail the requirements for grounding electrodes. Understanding the different types of electrodes such as ground rods, metal water pipes, and concrete encased electrodes, and how to properly bond them together is essential for creating an effective grounding system. 27th, study conductor ampacity tables. Tables 310.15b16 through 310.15b21 provide ampacities for various conductor types and sizes. However, these ampacities are based on specific conditions. You must apply correction and adjustment factors based on ambient temperature and the number of current-carrying conductors in a raceway. 28th, examine overcurrent protection requirements. Article 240 provides detailed requirements for overcurrent protection. You need to understand how to properly size circuit breakers and fuses based on the ampacity of the conductors they protect. This involves considering factors such as motor starting currents and appliance loads. 29th, investigate wiring methods and materials. Chapter 3 of the NEC covers wiring methods and materials. You need to understand the different types of wiring methods such as rigid metal conduit, electrical metallic tubing, and non-metallic sheaves cable, and their permitted uses. You also need to know the proper installation techniques for each wiring method. 30th, be aware of equipment listing and labeling requirements. Article 110.3b requires that listed or labeled equipment be installed and used in accordance with any instructions included in the listing or labeling. This means you need to carefully read and follow the manufacturer's instructions when installing electrical equipment. 31st, learn about special occupancies and equipment. Chapter 5 of the NEC covers special occupancies and equipment such as hazardous locations, healthcare facilities, and swimming pools. These occupancies have unique electrical requirements due to the increased risk of fire, explosion, or electric shock. 32nd, consider voltage drop calculations. Excessive voltage drop can cause equipment to malfunction or overheat. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Understanding how to calculate voltage drop is essential for ensuring that equipment receives adequate voltage. 33rd, understand the requirements for emergency systems. Article 700 covers emergency systems, which are designed to provide power to essential equipment during a power outage. You need to understand the requirements for emergency generators, transfer switches, and emergency lighting. 34th, examine the rules for fire alarm systems. Article 760 covers fire alarm systems, which are designed to detect fires and alert occupants. You need to understand the requirements for fire alarm control panels, smoke detectors, and notification appliances. 35th, think about the NEC enforcement and interpretations. The NEC is not a law itself but is adopted into law by local jurisdictions. The authority having jurisdiction is responsible for enforcing the NEC and for interpreting its requirements. 36th, remember the importance of continuing education. The electrical industry is constantly evolving, with new technologies and code changes being introduced regularly. Continuing education is essential for staying up to date on the latest developments. By continually learning and refining your skills, you can become a more competent and confident electrical professional. This ensures safe and compliant electrical installations.